Hello and welcome to 4th grade Unit 6. This unit is going to talk about fraction concepts and operations. Please have your note sheet available and a notebook to take some extra notes and to try some extra practice problems. Here we go. The first thing we're going to talk about is equivalent fractions. Equivalent fractions mean that we can break a whole into more pieces, but we still would have an equal amount of that object. So like 2/3 is the same thing as 4/6. If this was a pie and we ate 2/3 of it, or we ate 4/6 of it, we're eating the same amount. That is also true for 8/12. The thing to keep in mind is that if you multiply or divide a top number of a fraction, you have to multiply or divide the bottom fraction by an equal amount. Let's give it a try. If we have 2/3 and we want to move to something over 6, we have to think, what times 3 gets us to 6? And we know that that is 2. So what we do to the bottom, we do to the top. So we're going to do 2 times 2, which will get us to 4. We're going to start at the beginning fraction again and go, what times 3 gets us to 15? And we know that it is times 5. So what we do to the bottom, we do to the top. 2 times 5 equals 10. Those are equivalent fractions. Moving on to unit fractions. The word unit means one. So we are looking at one piece out of a whole. So we can see our shape down below is broken into 4 parts. The unit of it is one piece of it, which would be 1 out of 4. If we had an object broken into 5 pieces, our unit fraction would be 1/5, and so on. We can write fractions, like our example shows, by creating a unit fraction and a product of a whole number and a unit fraction. So if I have 4/7, I'm going to change to a shading tool here. I can shade 4 of my pieces. 1, 2, 3, 4 of them. So that already gives me my answer. I know that I have 4/7. Now we want to write it as a unit fraction. If we look at our unit is 1 piece. So our unit is 1/7. If we're writing it as a product of a whole and a unit fraction, there's our unit fraction. We need our whole number, and a product means a multiplication problem. So 1/7 times, how many of those 1/7 did we have? We had 4 of them. So that would be our whole number. Now we can write this in either direction. We could have done our whole number first and then our unit fraction, or our unit fraction and then our whole number. Our next concept here is going to be converting mixed numbers and improper fractions. In order to change from a mixed number, which has a whole number and a fraction, to improper, we can do big times bottom, so our big number times our bottom number, plus the top number. The reason we can do this is if I have 6 whole objects, that means I have 6 pies that have 5 out of 5 pieces. So if I have 5 out of 5, 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 6 times, really I would have 5 times 6. So it would be 30 pieces, but I had that 3 left over on top, so we need to add that to our amount. So big times bottom plus top is your top. The bottom number stays the same. In this case, our bottom number was 5. Let's try our example problem for this. If we have 6 and 1/5, we're going to do big number times our bottom number, because that's how many whole pieces we had, plus our top number, because that's how many are still left over our bottom number stays the same. So if I do 6 times 5, I get 30, plus 1, I get 31 over 5. And that would be my answer for our improper fraction. Improper just means your top number is bigger than your bottom number. Now the next part over here, we're changing improper to mixed. Fractions are division. So if I look at this is just a division symbol. I can think of this as a division problem, where your top number is the inside number and your bottom number is the outside number. So 47 would go on the inside and 5 would go on the outside. So now we're dividing. How many 5s can go into 47? We know that 9 times 5 is 45. We subtract that out, we're left with 2. What that remainder means is we had 2 pieces left over out of what we were dividing by 5. So my answer would be 9 2/5. Let's take a look at another example. Feel free to pause the video and try it on your own. Resume to see how to solve it. So this would be 3 on the outside, 8 on the inside. 3 goes into 8 2 times, with 2 left over. So our answer would be 2 whole and 2 out of 3 left over, or 2 2/3. Going to our next type of problem. This one did not show up on your note sheet, so you're going to want to pause this video and take some notes in your notebook. Multiplying fractions by whole numbers. All whole numbers can be turned into a fraction. We can turn it into a fraction by putting it over 1. Because if I had one object and it was broken into one piece, and I had that whole piece, and I had 5 of them, I would have 5 wholes. So we can create it as a fraction to help us understand and solve our problems easier. Now, when we multiply straight across the top and straight across the bottom. So we get 5 times 2 and 1 times 3, which gets us 10/3. 10/3 is an improper fraction, where our top is bigger than our bottom. So we're going to want to convert that as our last step to a mixed number. 3 goes into 10 3 times with 1 left over, so we get 3 1/3. Feel free to pause the video, try the example on your own, resume when you're ready, or just follow along as we solve this problem with the steps on the side. First, we put 8 over 1. We multiply straight across the top. 8 times 2 is 16. And we multiply straight across the bottom. 1 times 5 is 5. We then convert our improper fraction to a mixed number. How many 5s go into 16? That would be 3. 3 times 5 is 15. So how many is left over out of the 16? That would be 1 out of the 5 on the bottom. So 3 1/5 would be our answer. The next topic we're going to talk about is adding mixed numbers with like denominators. The denominator is the bottom number, so when our bottom numbers are the same, it's pretty easy to add our numbers. The first step you're going to want to do is take your horizontal problem and write it vertically. Then we start by adding our fractions together. When we add fractions, we only add the top numbers. 4 plus 3 is 7. And we leave our denominator the same, 6. We then add our whole numbers. 4 plus 5 is 9. Now, if we look at this, this is an improper way to write a fraction. We cannot have an improper fraction with a whole number. So we then need to convert our answer. How many 6s go into 7? 1 whole. So we're going to make the 9 a 10. And how many is left over if we took 1 whole out, which would have been 6 out of 6? We're left with 1 piece out of 6. So our answer is 10 1/6. Let's give our example a try. If I have 4 plus 3, I have 7, and I leave the bottom the same. Then whole numbers, I have 1 plus 1 is 2. So that's an improper fraction. We're going to convert it. We get 3 whole now because we're going to take a whole fraction out. If 5 is our total amount of pieces, we're going to subtract the 5 away from the 7, which made that 2 1 bigger. And we are left with 2 pieces on top out of the 5. So that would be our answer, 3 2/5. Subtracting mixed numbers with like denominators is probably the hardest concept in this unit. And the biggest reason is we are going to have to learn how to borrow. So we're going to repeat the steps of adding fractions. Line your fractions vertically on top of each other. Now, when we're subtracting, if the top fraction is smaller than the bottom fraction, we're going to need to borrow. So we take 1 away from the whole number. Now, this is where it's different than borrowing from whole number to whole number. We are actually borrowing a whole fraction. If we look at our fraction, if we had a whole fraction of this, we would have 5 out of 5. So when we borrow, we are borrowing whatever the total number on the bottom is. So we can add that bottom number to the top. We are not just adding 10 to it, like when we borrow from a whole number to a whole number. So what we are borrowing is a whole fraction. So we make the 7 a 6. We borrow a whole fraction, so we add 5 to the 3. And we end up with 6 8/5. We want this odd-looking fraction, this incorrectly written fraction, in order to subtract. Now we can subtract. Start with the fraction. 8 minus 4 is 4. 5 was our bottom number, so we keep it 5. And now we have 6 minus 3, which is 3. Take a look at these examples. Pay attention to how we borrow. So in this first one, I have 1 minus 2. I cannot do. So I borrow from the 7. I'm going to cross the 7 out and write a big 6 next to it. What I'm borrowing is a whole fraction. If my fraction says it's out of 6 pieces, a whole fraction would be 6 out of 6. So we're going to add 6 to that fraction, which gets us 7/6. Now I can subtract. 7 minus 2 is 5, and we keep the bottom the same of 6. 6 minus 3 is 3. Now we're going to simplify our answers when we can. This answer is as simplified as we can get because 5 is a prime number. This bottom problem is kind of tricky. A lot of people would just subtract the whole numbers. However, we can't do that. We can't subtract nothing by 1/4. So we need to borrow. So we're going to take 1 whole from the 6. Now if we look at the bottom fraction, we know that a whole fraction is out of 4 pieces. So if we had a whole fraction of it, we would have 4 pieces out of 4. So when we borrowed from the whole, we gave ourselves a whole fraction. Now we can subtract. 4 minus 1 is 3/4. And 6 minus 1 is 5. Which gets us our answer. Please make sure you borrow when you're subtracting a whole number by a mixed number. Moving on to our example problems. Give these a try on your own. If you're confused, stuck, feel free to rewatch the video. Otherwise, continue the video to see the answers. Welcome back. All right, the first one talks about creating a product of a whole number and a unit fraction. So we have 3 pieces shaded. So that is our whole number. A product means to multiply. Our unit is 1 piece. So that is the 1/4. And then we get our answer of 3/4. A recipe calls for 2/3 cup of flour. Dane uses 3 times as many cups of flour. Choose the number of cups of flour he uses. Mark all that apply. So this would have been a multiplication problem. 3 times 2/3. If I put that 3 over 1 and multiply straight across top, straight across the bottom, I would get 6 out of 3. And that's how we got answer B. Now we can convert this, because that was an improper fraction, by dividing. 3 goes into 6 2 times, and that is how we get answer C. For choosing the correct operation, if we started with a 6, and we do something to that 6 with 3/4, and we get an answer of 4 2/4. Our answer is smaller than what we started with. So that should tell my brain I'm subtracting or multiplying. Now that seems like a little bit of a weird concept, but when we're multiplying by fractions, our answer gets smaller. When we multiply by whole numbers, our answer gets bigger. So in this case, if I did 6 and I did times 3/4 we can put our 6 over 1 times 3 over 4. I get 18 fourths. If I divide that out, 4 goes into 18 4 times, which would have been 16. And then if I do 18 minus 16, I get 2 fourths remaining. So that's how I know it's multiplication. Also, if I had 6 and I subtracted 3/4, I would have had 5. If I have 3 and I end up with 2 3/5, 2 3/5 is almost 3. So if I only subtract a part out, that's the answer I would get. This next part is adding and subtracting our fractions. So we start by adding our fraction. 2 plus 2 is 4. We keep 3 the same. 5 plus 4 is 9. Now that's an improper fraction, so we're going to want to convert it. 3 goes into 4 one time, so our whole number goes one bigger. And if we subtract 3 away from 4, we're left with 1 out of 3 pieces. We could not do 3 minus 7, so we had to borrow. The 9 becomes an 8. We add our whole fraction amount, which is 8, and we get 11 eighths. 11 minus 7 is 4 eighths. 8 minus 3 is 5. Now, I could leave my answer as 5 4/8, but that's not the best answer. I can divide 4 and 8 both by 4 and get an answer of 5 1/2. That would be our most simplified and best answer. The next one, if we're taking 11 fourths and turning it to a mixed number, we're going to do 11 divided by 4. 4 goes into 11 2 times. 2 times 4 is 8. We subtract it away and we get 3 left over out of the 4. So our answer is 2 3/4. Changing 4 3/5 to an improper fraction, we do big times bottom, so 4 times 5, plus top is top, 23. Bottom stays the same, fifths, so we get 23/5. Please feel free to rewatch the video if you need more explanation of any of the parts. Working on IXL Skills Plan, Grade 4, Unit 6 helps. Also, working on Math Expressions, the Activity Center lesson checks. Good luck!